So far, we've loaded in our dataset and explored it a little using parts of speech tagging and named entity recognition. Now we're ready to start pre-processing our text data. We've covered this a few times now, so I'm hoping you'll be an expert in cleaning up this data. First, let's run data.head just to refresh our memories on what this dataset looks like. So you can see we've got the title column, the text column, the date, and the fake or factual tags. We want to clean up just our text column. You'll notice some rows in the text data have a location tag at the start of the text. So for example, in the bottom two rows, you'll see Washington and Belfast. There's also the router's name in there, followed by a hyphen. We want to clean this up and remove it because it feels like it might impact our analysis a little bit. So how can we do this? Well, we can do it using regular expressions. The aim of this regular expression we're going to create is to look for this hyphen and remove everything before that first hyphen. So we want to create our new column, text clean, that's going to contain all of our cleaned up text. We'll then use data.apply to apply our re sub function over the rows in our dataset. So we'll specify lambda x and then use re sub, an irregular expression. This regular expression is probably going to look a little complicated, but essentially what it does is look for the first hyphen in the text and remove the hyphen and everything before it. If you do struggle with creating a regular expression for your problem, I definitely recommend having a Google because there's usually someone who'll have the same problem and will have provided a solution for you. There's also some great regex generators online that you can use to help create the regular expression syntax you need for your problem. So we specify the regular expression syntax and we want to replace this with blank. So essentially we want to remove it from our text. We then specify we want this to run over the text column and our axis equals 1. So if we go back and run our data.head again, we can see that our text clean column has been added and those location tags have been removed. Our next step, as I'm sure you'll remember, is converting our text into lowercase. So we take our text clean column and then we just apply .str.lower. We then want to remove our punctuation, so this is the same code as we used before for our regular expression, except we're just switching out the syntax. This syntax will be the one you recognise that we've used to remove punctuation in our other lessons. It's basically looking for anything that isn't a word or a space and just removing it. So again, we'll run data.head and we can see that our text clean column has been nicely converted into lowercase for us. We'll then move on to removing our stop words. So we'll specify the stop words we want to use, we'll create en stop words, this equals stopwords.words, and we'll specify the language of the stop words that we want, so English. We'll then print these stop words out and have a look at what's in there. So when we did our POS tagging, you'll remember I said it was important to compare those frequently occurring tokens against our stop words list. So here you can see we had the really common tokens that were mostly stop words, so the, of, a, and. So it's really important to go back and sync that up with your stop words list and make sure that all those really commonly occurring words that you can remove are in that stop words list to be removed. So I know that these tokens we want to remove are in the stop words list, so we can go forward and just straight up remove them. Again, let's check our pre-processing by rerunning our data.head. So when we look at our text clean column and compare it to our text column, we can see that stop words have been removed. Now let's jump into tokenizing this text. This will go through each of the rows in our dataset, take the text from text clean and convert it into our word tokens. And our final step in pre-processing is going to be lemmatizing. We're going to be using lemmatizing instead of stemming because I want to use this more intelligent method to keep a lot of the context and meaning of the words where possible. Our dataset isn't too large, so it shouldn't take too long to run and won't cause too much of an issue later down the line. We've specified our lemmatizer as our WordNet lemmatizer, and then we use lemmatizer.lemmatize, and in the brackets specify our tokens for token in tokens. Let's check this last bit of pre-processing. And great, you can see that TextClean has been tokenized and lemmatized successfully. Now that we've cleaned that up, let's see what our most common n-grams look like after we've done this pre-processing. So we'll create a list of our clean tokens and then go on to look at the unigrams. So we create unigrams and then we want to create a PD series and we'll use nltk.ngrams over our tokens clean. We specify the value of n as 1 because we're just interested in unigrams. We then want to take the value counts. And we can print this out up to the top 10 to get our top 10 most frequently occurring unigrams. So we can see this is much more interesting after we've done our pre-processing. It's not just stop words anymore that are coming up as our most frequent tokens. We've got much more interesting words coming out here. So let's turn this into a plot so we can put it into any presentations or discussions we're doing with non-technical people. We'll use the Seaborn package, so we'll use sns.barplot. We'll specify our x and our y. We want to specify the orientation as horizontal, so we use H. And for our palette, we're just going to be using the default plot color we specified at the start of our notebook. Of course, we also want to add a title, so we'll name this chart Most Common Unigrams After Pre-Processing. And once we've run that, it's given us a nice chart we can use of the most common unigrams in our dataset. Let's see if analysing the bigrams give us similarly interesting results. So we'll copy this code over and just switch it out to bigrams, making sure to remember to change the value of n from 1 to 2. So here again you can see we've got some really interesting bigrams coming out, such as Donald Trump, the United States, White House, etc. So now that we've cleaned up our dataset and got it all in a nice format, let's move forward with some additional analysis.